Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 16 from the 2016 exam. It reads, which one of the following reactions would not produce current at 25 degrees when set up as a galvanic cell? So we've got, these are the selections we're supposed to choose from. This is just the table, reduction potential tables I want to use for working out this question. Now, the other way this question could have been worded would have been, which one of the following would be a non-spontaneous reaction, or which one will produce a negative electrode potential at standard conditions or at 25 degrees. Now, let's take a look at what we have here. The first equation, we've got permanganate ions interacting with ion 2, producing manganese ions and ion 3. Some of you will be wondering, why is it that I'm ignoring hydrogen? Because I know that all the reactions, the H plus ions are just representing the acid, because these reactions must be acidified, some of them, for us to get the oxidation of the permanganate ion from +5 here. Is it +5? This is -2, -8. Yeah, to get it from +5 to +2, right? Otherwise, it won't actually, it will go to all sorts of oxidation states here. So we add a few drops of acid. That's why we've got H plus here. Now, and I'm ignoring that as well, because if I do a quick inspection, hydrogen's oxidation state is not changing. Oxygen is not changing. These are redox reaction. I'm only focusing on species that have got oxidation states that are changing. Now, back to what we have. So I've got two half equations there. The first one is permanganate ion going to Mn2 plus, and I've got another one where ion 2 going to ion 3. So this one is my oxidation process. Right, and I would say oxidation takes place at the anode. So this half equation, if I was setting this up, this would be my anode and this should be my cathode, right? I'm sure you would all know the mnemonic N, oil, rig, cat, which means at the anode, oxidation takes place and reduction takes place at the cathode. So that's what this mnemonic tells you. So what we need to do is to find the voltage or the standard electrode potential for these ones here. So when we go in here and look for the equation where we've got permanganate going to Mn2 plus, and we know that we've been given that this one here, if it's going that way, the voltage is positive 1.51. And if we look at the ion half equation, which is this one here, right, you can see it has been reversed. Why? Because we're going from ion 2 to ion 3. Ion 3 is a product in this instance. So we have to reverse our electrode potential to make it minus 0.77. If I add this to 1.51, take away 0.77, I am going to get a positive electrode potential, which means this reaction, yes, it will produce a current. Now, let's look at ion going to ion 2. That's the next half equation I've got here. I've got for B, ion going to ion 2 plus, and the other one is lead 2 plus producing lead. As we can see, this is our reduction process which means it's going to be the cathode. This one is going to be our anode. You didn't need to work this out, but just since it's revision, I'm giving you that so that you would know which half equation would have been the anode, which half equation would have been the cathode. So when ion is going to ion 2 plus, where is the half equation for that? Is this one here. And since the process has been reversed, how do I know it has been reversed? Because I'm now starting with ion, and ion 2 is my product here. But the table is giving us that if you start with ion 2 as your reactant going to ion, the electrode potential is minus 0.44. But here, because we're going the opposite, we change that electrode potential to positive 0.44. Now, lead 2 ions, where is lead 2 ions? Lead 2 ions going to lead. This is the half equation we're looking for, right? And this one here is in the right, it's arranged the proper way. So this one is going to be minus 0.13 because we start with lead 2 plus, end up with lead, and here we're told that the reactant is lead 2 plus going to lead. So this one here is going to produce a positive electrode potential. If we just say plus 14 plus 0.44 minus 13, this is going to be a positive electrode potential. You don't even need to work out the value. If you can quickly do the maths and figure out that my positive number is bigger than the negative number, so the overall result is going to be positive. So that one is fine. Let's look at the next one, C. We've got bromine going to bromide ions, and the other one is chloride ions going to chlorine. Right, let's look for these half equations here. The bromine going to bromide ions, this one right there, it's bromine, it's 1.08, and chloride ions going to chlorine is going the opposite way, so we have to change this one here and reverse that one. It becomes minus, this one is positive, minus 1.36. In this case, our negative value is absolute, right? We've got a bigger than this one here, the absolute value. So if we say plus 108 minus 1.36, we're going to get a negative E value. So C should be our correct answer. It's not producing any kind of current there because the voltage is negative. Now, ion going to ion 2. Ion going to ion 2, we've got that here. The first one, ion to ion 2, it's plus 0.44. I'm analyzing the last one. There is no need for me to write this one because I've already figured that out earlier. And copper going to copper 2 plus ions going to copper. Where is that half equation? It's right here. So copper 2 plus 1 going to copper, it's plus 0.34. This is going to produce a positive voltage. So the only process that has got a negative electrode potential is C, which means it would not produce a current. So my correct answer for this one should be C. I hope to see you back when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.